We're here today to talk about legacy code and unit testing. I've titled this, What Will Be Our Legacy, With or Without Unit Tests? And my main motivation for doing this is I do work with a lot of teams that are heavily involved working on legacy code. It wasn't necessarily their code that they wrote. They inherited it, and sometimes it has unit tests already, sometimes it doesn't. But the common denominator is that this legacy code is going to be around for a long time. They often have a difficult time maintaining it and deploying it. And so usually it's because there aren't very many or the unit tests are not very good. So I want to make sure that we figure out how to embrace really good engineering discipline around this, and that we're not just writing unit tests for the sake of writing unit tests, that we're writing good unit tests and improving the code base overall through them. So that's really the big motivation that we have for today. The things that I'll be talking about are, really what is legacy? What is meant by that? Also want to talk about what good unit testing is, what a singular good unit test looks like, and what a good unit testing approach looks like. I want to also go through some specific prioritization techniques for figuring out where you should be writing your unit tests, and then cover one refactoring pattern, unit testing pattern that you can go and work with your teams, work in your legacy code to start writing some good quality unit tests. And that should be plenty for today, honestly. That's be a pretty solid agenda. All right. So a little bit about me. Maggie said that I'm with LitheSpeed. I've been doing Agile for about 20 plus years. Actually started in XP, extreme programming, a lot of Agile engineering discipline there. And as I said at the beginning of this, I've worked with a lot of different teams, and I always managed to find my way to working with teams who struggle with legacy code, which is a large part of the reason why I was inspired to put this together. So, what do most people think of when they hear legacy code? Javier says, code that can't change. Old mainframe. Potentially. Outdated, I see, yeah. Yeah, definitely. Those are some really good ones. And the mainframes, I've definitely been at some organizations that still rely on mainframe. We won't really be talking about mainframe today, but yeah, something that will continue on forever. Monolith, 15 plus years old. Doesn't necessarily even have to be that old. I would say that a lot of people, when they hear legacy code and they hear, you're going to be going to a team where the product will be largely legacy, they think, well, look at the size of that thing. I have a very bad feeling about this. Bum, 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 ba-dum, bum, ba-dum. Legacy code, right? It's like a Death Star. It's going to destroy you and your will to live, all of these things. And a lot of this can be true. And judging from some of the comments I saw in the chat, that definitely seems to ring true, resonate for you. If we look at some definitions out there in the industry, some of the biggest ones would come from Michael Feathers. He wrote a book about 20 years ago called Working Effectively with Legacy Code. And he says, at least to him, it comes down to code without tests. So, it doesn't necessarily have to be mainframe code, doesn't have to be 15 plus years. You could have written some code very, very recently, and it doesn't have tests. And under Michael Feathers' definition, that would qualify all by itself as code without tests. He does get a little bit more specific and will say that it's tangled, unintelligible, code that you have to change, but you don't really understand, sleepless nights, demoralization, the sort of code that you wish would die unworthy of your efforts. And I definitely think a lot of people will identify with those definitions there. And I think this last bullet that's from Beyond Legacy Code, that book just says living code that's difficult to change. And judging from some of the comments I saw in the chat, that looks like something that would resonate with y'all as well. I know that many of the teams I work with will say, this is legacy code. We just can't deploy it very frequently. And they'll card out all kinds of reasons for why that is the case. And a lot of it comes down to the fact that they have to run a whole lot of manual tests, and the manual tests take a really long time. They're simply not repeatable. As soon as you run it and you get results from it, you have to throw it away. The next time you have to run that test, you have to run it manually again. And it takes a long time. And therefore, it's really difficult to change. And maybe to extend that metaphor of the Death Star, I imagine that a lot of people think, oh my goodness, I'm going to have to write a little bit of code against this legacy system. Even the littlest thing might cause some sort of a chain reaction and the whole thing might explode. And while that led to a whole lot of celebrations across the rebellion, that's not the kind of celebration that we want when you go and destroy a massive system with one tiny little change. So that's not necessarily where we want to go, but I think we can go to a better place, because the fact of the matter is that these legacy systems are going to be around for a long time. They're still providing value. And, in a sense, that's some good news. They are out there providing value. If they didn't, we wouldn't need to produce some enhancements, some new features to them. But the bad news is that there are some engineering difficulties that are significant obstacles to the way that we do our work. And if it weren't for that, we would be able to flow change through a lot more easily. And so that's where we come in here and try to figure out how to steer our legacy systems to a place where not only are they continuing to provide value, but they're providing value in a better way that's flowing the value out much more quickly, in the way that we would want a well-engineered system to be behaving for us, right? So, often in the industry, we talk about how everyone should be doing TDD and there should be greater than 90% coverage, all of these things. But the reality is that there are just some agile things that are very difficult for some teams to do. That's just a fact. Some of it is because these teams are working in monolithic architectures where there wasn't unit testing written from the beginning. And so they don't have that strong base of test coverage already available to them that they can build on very easily. So while we would like to have TDD, we would like to have great code coverage and a great architecture, we simply don't. And I think we need to recognize where teams actually are. And by recognizing that should help us figure out how to get them and encourage them to embrace the right behaviors, and in ways that they will that are sustainable, will help them continue doing some of these things incrementally, using good practices. What should good unit testing look like? Now, I was reading a really good book. I think it came out just a year ago, called Unit Testing Principles, Practices, and Patterns by Vladimir Korakov. And I really liked his description of what unit testing should look like. At the individual level, it should be resistant to refactoring. And I'll pause here and go into a little bit of detail about what that means and why it's profound, and a little bit different in many ways to what might have been a traditional approach to automated unit testing and TDD, test-driven development, at a certain level. So to his way of thinking, and something that I think is really good, unit tests should really only be testing observable behavior. And that also means that even though unit tests are aware of the implementation details of our code, they really do know what the structure of our classes and our methods are. We shouldn't necessarily build that knowledge too much into our unit tests. If our unit tests are testing for the structure of our code, then what can happen is the structure of our code sometime in the future can change, and the behavior might not. In those cases, the unit test that is testing for the structure of the code will fail, even though the behavior of our system has not changed. To Mr. Korokov's way of thinking, that would mean then that that unit test was not resistant to refactoring. In fact, it was very sensitive to the refactoring and failed as a result, and that would make it not a good unit test. Of course, we want to make sure our unit tests protect against regression. So that's kind of the opposite side of that coin. We want to make sure that when our system does have its behavior change, that there's a test somewhere that is able to detect that and warn us that something changed that should not have changed. And that's where a good unit test would step in. And of course, our test should be very easy to read, very simple, straightforward, testing a very simple single behavior. And all of that would lead to those unit tests being more maintainable, not just by the person who authored them in the first place, but by anyone who would come in onto the team later on, and accept it as maybe some sort of legacy, right? And they should provide fast feedback. All true unit tests should avoid crossing any architectural boundaries, and they should run super fast, like in the order of just a couple of milliseconds. If they take longer than even 1 second, then they're probably too slow. We want really fast feedback. We want to literally be able to run hundreds of unit tests in a matter of a few seconds, okay? So that's at the individual level. As an approach, we want to make sure that our unit testing approach is integrated into the development cycle. We don't want to write a lot of code and then have to backfill our code later on. We want it to be done incrementally all along the way. We want to make sure that our unit tests are targeting only the most important parts of our code base. If they're targeting trivial parts or things that simply aren't valuable, then they're really not. It was probably a waste of time to write them in the first place. And we want them to provide maximum value with minimum maintenance costs. We shouldn't have to worry about going and changing and refactoring our unit tests endlessly. We should go and refine them and refactor them, periodically, but the maintenance costs on these should be low so that we can really focus our attention on the application code, the part of the code that's going to be providing value to our customers. Now, this is an approach for all unit testing, whether you're doing test-driven development or you're unit testing legacy code. This applies to all unit testing, and I think it provides a nice rubric for how we'll look at things as we go forward. Let's think about this rubric as we go forward, because I think where this really applies to some of our legacy code and the teams working on it, one of the things that is a consistent obstacle to them is that organizations will tell them that they must achieve a minimum level of test coverage for all of their applications across all of their code, or they cannot deploy. And the reality is that a lot of legacy code has little to no unit testing, and it's not easy to backfill. Just a few minutes ago, I was talking with one of the teams I work with, and we specifically talked about how difficult it can be to test code that wasn't written in a testable way to begin with. And that really is one of the the pitfalls of legacy code. And yet, organizations will cling to code coverage as a really important metric and will use it as a carrot and a stick for their teams. But let's think about it. Let's think about it in light of that rubric I just went over. If your team has to achieve 60% minimum test coverage, and they're at 0 right now, then they're going to have to spend weeks backfilling some of it to get up to that minimum threshold in order to get some of the latest features out the door and into production. So what does that mean? So here's the rubric. What often happens is that tests will be written to satisfy a coverage metric, and they'll often be written against trivial code. The trivial code, will probably have very few, if any, dependencies on it, and that'll make it a lot easier to write against it, but it's really not valuable business logic that is driving what the customers really want. So what's the problem with that? Well, it doesn't protect you against regression. If it's trivial, it's definitely out of the way, and something else somewhere in the system will likely break and you won't find out about it, even though you might have 60% test coverage. The fact that you are backfilling and writing it much after the fact means it was not integrated into your development cycle, and it's not targeting the most important parts of your code base. Okay? What else? One thing I have seen is that teams will cheat. They will understand that there is a way to work this metric and get some test coverage without actually having any assertions. So you'll get credit for the coverage. That code will never fail. That test will never fail, ever, because there are no assertions, nothing that says, well, this should have happened, did it? And so the problem there with our rubric is that you're definitely not providing maximum value with minimum maintenance costs. And you have something that's not super maintainable. You didn't have to refactor anything in order to get that code coverage. And so you're not helping anyone who's going to come along later on. These are not very good, not valuable tests. And inevitably, teams that follow this pattern will drop below 60% again, and they'll have to go and repeat this cycle, which is kind of a vicious cycle. And another thing that often happens that I see is that teams get jaded against the very idea of writing unit tests in the first place. They'll think, well, if this is what writing unit tests is all about, then that seemed like a waste of time. I could have been writing actual code that provided value. Instead, I wrote some tests that are never going to break. They're never going to be signaling anything. I just wasted 2 weeks of my life and some other people's lives writing stuff that didn't do anything for me. And so I'm certain that this is not the culture that we want to promote going forward. Okay. So what would be a better way? What we want to do is first take some sort of a risk-based approach to figuring out where are the most important parts of our code base. Often, especially in legacy systems, there will be areas of your code that you are continuing to extend and enhance, build new features into. Those are the ones that are going through the highest frequency of change and are probably the highest risk. And that's where we really want to prioritize writing some unit code and potentially refactoring some of that code so that it is more testable. The parts that are really not going through any change and are therefore lower risk, we don't want to write unit tests against that. That would be a waste of time. We want to target the most important parts of the code base, the ones that are going through a lot of change, highest risk. That's where we want to go and write our unit tests. All right. So that'll be one part of a quadrant. Now we're going to look at a quadrant within that quadrant. So the first one is, where's the most change? So within that quadrant, we want to figure out where can we get the most value from the unit testing. And even within the parts of the code that are undergoing the most change, there are going to be some areas that would provide some different value for us as well. So the two dimensions that we're going to be concerned with here are the level of complexity some domain significance, and the number of collaborators. All right. So one thing, especially in systems that are written in either Java or .NET, that you'll see is there are patterns called like model view controller, which do a nice job of separating out some of these dimensions, at least theoretically. And it's really where the controllers are and where our business logic is, where we want to focus the most attention. So in this quadrant within the quadrant, let's focus on the business logic. That's really the area of our code that is most directly connected to our users' goals. And then the controllers act often as some sort of a dispatcher. They'll be where there's some logic that understands how to connect some of the business logic to some things that'll actually be interacting with users. And they'll be collaborating with a lot of different aspects of our frameworks in order to do some of the things like sending out emails or interacting with the database or sending messages out through a message queue or any number of other things. Those also need some level of unit test coverage. The trivial code, though, you should stay away from. Don't worry about achieving any coverage in things that are maybe even generated by your IDE, getters and setters, things that contain neither business logic nor any kind of controller logic. So stay away from that. But the area that we really probably want to focus our attention on is this top right quadrant. And that's the overcomplicated code. Often what we will see there is that the overcomplicated code is sometimes tightly coupled with the framework. Sometimes you'll see a lot of interspersal of business logic with some of that controlling logic. And where we see things like that, where they are interspersed, combined, it's a good idea to figure that out, find it, and start splitting it apart. Okay, and that's why we have those arrows going in those different areas. Take some of the overcomplicated code, push it down to the controllers, and push some of the others to the left to the business logic. All right, so that's easily said, but how specifically would we go about doing that? But a word of caution before we actually embark on any refactoring, because that is what we will be doing. We want to make sure that we practice safety first, always. Sometimes, even though it won't be a unit test, it might be a good idea to write some sort of a simple black box test. Might go through a user interface or something that can verify the behavior that we're expecting before we do the refactoring. Therefore, we have some sort of a safety net in place that will tell us if we broke that behavior by doing the refactoring, and we can roll it back and try again in that case. It's much easier to do that if you have that safety net in place from the very beginning. Okay, so here's where I introduce just one pattern. It's basically all we have time for today to figure out how to do some of this refactoring and figure out how to move some of that overcomplicated code out of that top right quadrant into the other quadrants. And a really good pattern for that is called the humble object pattern. It was articulated by Gerard Metzeroche in his book XUnit Test Patterns, Refactoring Test Code. And really what he saw was exactly what we're seeing in that top quadrant. There's some code that's hard to test because it's tightly coupled to our framework. There are lots of dependencies. Maybe you have some asynchronous processes that are almost impossible to do any true unit testing against. They cross some architectural boundaries. because they're asynchronous, there's no way to test that the thing actually happened, because who knows when that's going to happen on the other end. And that could be sending an email, that could be putting a message on a message queue, it could be any number of things that could be happening outside of this process. And because of that, maybe that's the reason why the original team didn't write that test in the first place. It was just difficult to do it, and so they didn't. But we're going to talk about this pattern because it is actually possible to achieve this. And the way that you do it is you start by extracting from that hard to test dependency the business logic. And that business logic will be synchronous and very testable. And then you put this humble object that is really just a thin layer that is in front of the business logic, that is there to provide any context to that business logic class that you might need, that would have otherwise been very tightly coupled to that hard to test dependency. Because this is testable, you can now write an actual test, a synchronous test, a unit test against the business logic. And the humble object will be standing there as kind of the glue between the business logic and your dependencies. And if there's any context that you need in order to test the business logic, you'll be able to grab that context very easily from the humble object and test accordingly. Okay. One of the huge advantages here is that the humble object, being as humble as it is, has almost no logic itself in it, and so you don't even really need to write a test against it. But now the business logic that is providing a whole lot of value to your users has some tests against it, and they're valuable tests, and they should be very simple and resistant to refactoring all of the great things that we want to see in our rubric. Okay. So what just happened when we did this, when we applied the humble object pattern to our code? Well, we started out with something with overcomplicated code. Likely had some collaborators in there, maybe some controller logic in it, and some business logic. Then we extracted from that overcomplicated code some business logic and that controller logic, potentially, into things that are testable. And when both of those things were testable, we wound up with better coverage overall, making it much easier for all of this to happen in a much better way. Let's go back to our rubric and evaluate this approach as opposed to the test coverage approach. And this is what we did. So we first took a risk-based approach to determine where unit tests should be written, and we refactored some complex code, untangling business logic from the controller logic. And what we have now are tests that are valuable, since they are written against parts of the code that are most likely to change, which is great. We have targeted only the most important parts of our code base, and I hope we've provided maximum value with minimum maintenance costs. So that's fantastic. Our tests are concise, easier to maintain, and they're less prone to false negatives or false positives. And the false positives tend to be the tests that fail because of refactoring, and the false negatives are the ones that fail because of some regression in our behavior. So we're able to do that. We have more maintainable code. We have unit tests that don't have to cross any architectural boundaries. Therefore, they are super fast and are providing us with fast feedback. And perhaps the most important part is that teams should be able to see some value in this approach and are more likely to continue with it, which makes it so that it can be much more easily integrated into their development cycle. All right. I would always hope that, as opposed to just blindly seeking some sort of test metric, such as 60%, if you're able to do this incrementally, small tests integrated into your sprints, written all along the way with all of the code, that this is an approach that developers on teams should embrace and see the value in and continue to do in a sustainable way all along the way. All right. So where do we go from here? So once we have understood what a good, valuable unit test is and a valuable approach to unit testing is, I would hope that we keep adding valuable tests. The ones that aren't valuable, quite frankly, we should get rid of them. I think that tests that are not valuable are imposing a pretty heavy cognitive load on the teams that are supposed to maintain them. And when they are not against valuable code, then they're not valuable tests. They're probably better not being in our repositories at all. Get rid of them. But we should also make sure that we are adding all of our tests in a timely manner as part of our development cycle. I often also subscribe to the first mnemonic of unit testing, which says that unit tests should be fast, independent, repeatable, self-validating, and timely. And I love the timeliness aspect of it, because I always want to encourage teams, developers, that the closer they write their unit test in time to when they actually wrote the development or the application code, the more valuable that test will be. If you wrote it the same day, that's great. Even closer to that's even better. Try to avoid writing them at the end of your sprint. Your tests won't really have the same quality as they would have if you'd written them at the same time. Even if you're not going to adhere to test-driven development and write your tests first, write them in a timely manner. Next, even though I've talked about coverage metrics, we still want to see coverage metrics go up, but we want to see the coverage metrics go up in conjunction with quality test coverage, right? So the new coverage metric that we're achieving all along the way should be our new baseline. If you started at 0 and now you're at 10%, that's fantastic. Don't go below 10%. Try to keep adding on and using these patterns all along the way. Keep exploring some other refactoring patterns. The humble object pattern isn't the only one out there. There are many others that can help you explore different ways to refactor your code to make it more testable. Even at the kind of the enterprise architectural level, there's a strangler pattern that's been championed by Martin Fowler, among others. And this is a pattern that you can use to move away from that monolithic architecture to microservices. But the main thing to remember here is, as you move towards your microservices and a better, more adaptable architecture, still please write those unit tests. Make sure they're valuable as you're going along the way. You don't want your good microservice architecture to be tomorrow's legacy system, one that doesn't have unit tests. Write the unit tests as you go along. And there's some wonderful books out there. Some of them have been out for a long time, all about working effectively with legacy code, literally. The one written by Michael Feathers, a wonderful reference, wonderful book to help you down this path. And then there's also Beyond Legacy Code, the one that was out about a year ago by Vladimir Korokov, Unit Testing, Principles, Practices, and Patterns. And then the X unit test patterns, the one by Gerard Messeroche, the one from the humble object pattern. Some wonderful stuff there too. So really, that's about it.